We enter the Cenozoic much as the Mesozoic ended, with the Farallon Plate grinding away at the base of the overlying North American Plate. This subduction erosion thinned Southern California's crust, leaving it vulnerable to tectonic stress. One model has a northeast to southwest trending oceanic plateau or aseismic ridge colliding and shearing off part of the plate's leading edge. Orogenic belts that were once continuous between the Sierras and Peninsula ranges were offset along the Nacimiento Fault. Coastal Southern California remained tectonically unstable, with uplift in some areas and subsidence in others. During the Paleocene, LA and Orange counties subsided and filled with sediment, while most of San Diego rose and eroded. By the early Eocene, that pattern flipped. Erosion struck LA and Orange as San Diego accumulated an exceptionally complete record of fluvial, lagoonal, barrier island, shelf, and slope deposits. Southern California's climate was much warmer and wetter than today, as global hothouse conditions prevailed. The concurrent rise in sea level augmented subsidence-driven transgression in San Diego and inundated much of LA and Orange counties. As hothouse conditions waned, sea level fell, exposing LA and Orange, while depositional environments regressed in San Diego. Headward erosion and stream integration then established the Las Palmas and Poway fluvial systems, tapping clastic debris from multiple sources, including the Jurassic continental arc. This mix formed massive fan deltas that prograded over former marine and paralic settings, while tectonic quiescence allowed erosion to bevel the region to a broad, near-planar surface. Over time, San Diego's cobbles became more locally sourced, as reactivated reverse faults lift the eastern peninsula ranges. Uplift now begins on the Colorado Plateau, as continued headward erosion in LA and Orange enlarge the Sespe fluvial system, while San Diego deposition wanes. Meanwhile, slowing convergence allows the subducted Farallon Plate to sink, triggering slab rollback and a return of arc magmatism across much of the region. These events set the stage for the climax of Southern California's tectonic story, the arrival of the East Pacific Rise at the subduction zone. The event brings the Pacific and North American plates into contact for the first time, opening a slab window inland from where Farallon Plate creation stopped. Because the Pacific Plate moved along and slightly away from North America, shear stress initiates the San Andreas Fault, while extension yields crustal thinning, core complexes, pull-apart basins, and related deposition across southern Arizona and southeastern California. On the coast, drainages shift to more local sources, while deposition becomes mostly terrestrial and shallow marine because the now inactive Four-Arc Basin had filled. A second rise segment reached the trench south of the first, creating another slab window and leaving a laterally detached piece of the Farallon Plate still tied to the East Pacific Rise. As the slab windows grew, stress focused on the bridging Farallon segment, which eventually yielded to opposing forces from the Pacific and Farallon plates. The Farallon remnant broke off as the Monterey microplate and was captured by the Pacific Plate. a stenosphere drawn into the widening slab gap decompressed, generating magma that fed patchy volcanism where crust had been thinned by extension or weakened along older structures. Carried along with the underlying Monterey microplate, a large block of the continental margin, the future western transverse ranges, rifts from North America. Further north, the Monterey microplate collides with the southern Sierran root, shearing off another sizable chunk of North America. The Selenian block now joins a growing list of oceanic and continental fragments captured by the relentless pull of the Pacific Plate. Extension between these blocks thins the upper crust, uplifting previously subducted mélange, the source of the San Onofre breccia. Load reduction also triggered decompression, melting, and volcanism, especially above slab gaps and windows. This profound crustal rearrangement created numerous deep marine basins along the California coast. Land proximity, cooler ocean temperatures, and uneven bathymetry made these waters nutrient-rich, allowing diatoms to flourish and leave remains that formed California's Monterey Formation, the state's primary source of oil. Breaking free from the foundering Farallon Plate, the Guadalupe and Magdalena plates are captured by the Pacific Plate, along with large slices of the Baja California borderland. Plate motion now concentrates along the Tosco Abrejos Fault and the northern San Andreas, while a mix of lateral faults and spreading centers accommodate the shifting blocks of the borderland. Regional uplift of the peninsula ranges follows, likely driven by isostatic adjustments from mantle upwelling in the wake of the fragmented Farallon. Meanwhile, much of the adjoining Proto-Gulf California subsides below sea level as extension and crustal thinning take hold. Pulled by the captured Monterey, Guadalupe, and Magdalena microplates, the entire Baja Peninsula joins the parade of migrating blocks as an en-echelon chain of transform faults and spreading centers forms along crust softened by the earlier Komandoo pulse of arc magmatism. The longest and most northerly of these transforms is the southern San Andreas, which now connects with the northern San Andreas via the Big Bend. Transpression along the bend thrusts cratonic rock over the north end of the peninsula ranges, rapidly uplifting the eastern transverse ranges, while the western transverse ranges rise as wayward borderland blocks impinge on and underthrust southern Selenia. These uplifts shed clastic debris that fills the Los Angeles basin, while in the Salton Trough, rift-driven subsidence outpaces deposition, so the Gulf of California deepens. Headward erosion on the Colorado River eventually captures an ancestral stream, diverting it into the Salton Trough, where a vast delta soon forms. Variations in crustal strength and shifting stress patterns produce a complex web of faults, each accommodating motion between the Pacific and North American plates. Although dextral shear dominates, local stress varies dramatically. The modern topography of Southern California emerges from this interplay: uplift in zones of transpression, subsidence in zones of transtension. Coastal transtensional basins fill with marine sediments, while the Salton Trough accumulates alluvial, lacustrine, and deltaic deposits as rifts propagate northward and the Colorado River episodically floods the basin. as the fault-bounded blocks of Southern California jostle and shift. Stress redistributes. Portions of transtensional basins already filled with sediment invert into elevated terrain when local stress switches to transpression. This is the mechanism by which many of Southern California's iconic tilted rock formations are exposed, and how most of its oil becomes trapped, aptly fueling the gasoline needed to drive to these places. Despite large variations in local stress, regional uplift generally outpaces subsidence. Combined with the fluctuating sea levels of the glacial ages, a series of marine terraces are carved and elevated. Holocene primates eventually find these desirable places to live. Some now ponder the epic saga of the land below.